front side of this? No, what about the back? Yeah, Tina? 18, perfect. What else? Looks like we did number 9 together. There it is, if you missed it. I want to talk about number 10 as well, because that's a fun one. Anything else on the back? Anywhere we got stuck? Have questions? No? Did you guys finish this all the way? Good. I hear some yeahs, I hear a few no's. Let's see, I'll just pick one. We'll do... Cool. That was the one I was looking at, 13. So let's start out with number 10. I got n squared equals 0. Okay, I've got n squared equals 0. If I want to get n all by itself, I've got to do the inverse of squaring a number, which is taking the square root. What I do to one side, I have to do to the other. So I square root both sides. Now, like we said in the warm-up, n squared, that's just n times n. How can we break up 0? What two numbers would multiply to give me 0? 0 times 0. Technically 0 times anything, right? But we're looking for a matching pair. So I get a 0 times 0. So now this looks like n times n equals the square root of 0 times 0. I've got a pair of n's that can be brought out on the left, a pair of zeros that can be brought out on the right, and I'm left with n equals plus or minus 0, right? But what's the interesting thing we know about 0? It can't be positive and it can't be negative, so my answer is just n equals 0. It's the one and only time we don't need a plus or minus, when our answer is 0, because like we said, 0 is neither positive nor negative. All right. If we went up here to the original equation, n squared equals 0, and we plugged in 0 for n, 0 squared equals 0. Well, what's 0 squared? It's just 0 times 0, which gives me 0. That's a true statement. 0 does, in fact, equal 0. Any other number we plugged in here and squared it would not give us 0. So that's kind of a little tricky one. 0 is always kind of weird to work with, but that's what we get there. No plus or minus needed. Dropping down to 13, same thing. If I want to get r all by itself, I've got to square root both sides. This is an imperfect square here, so all I got to do is break it up as much as I can. What two numbers would multiply to give me 48? 12 times 4. Awesome. Anyone do something different? 6 times 8. Perfect. 24 times 2. Right? Any of those would work out. I can split both of these up more. What two numbers multiply to give me 12? 6 and 2. Again, you could also do 3 times 4. 4 obviously is just 2 times 2. And what about this 6? 2 times 3. Now, I had some questions last week, I think in a different class, but how do we know which numbers to circle once we finish our factor tree? Well, it's any number that doesn't have branches coming off of it. So we're not going to circle the 6 because there's 2 branches coming out, but this 3 and this 2 have no branches underneath it. I know that those are 2 of my factors. I'm not going to circle 12 or 4 because they both got branched out. But all my 2's here are prime numbers. I'm going to circle those up. So this turns into r equals 3 times 2 times 2 times 2 times 2. Once we've broken it down all the way, we're looking for identical pairs. Is there any pairs in here we can circle up, Tina? Yeah, we can circle up a pair of 2's and another pair of 2's. This is another important thing we have to remember. When we have multiple pairs that we're bringing out in front here, right, this pair of 2's becomes a single 2. This pair of 2's becomes a single 2. What's left over in the square root? 3. It's my only number without a pair. And what do we do with these 2's in the front? We multiply them back together. That's right. Giving me r equals what? plus or minus 4 root 3. That was number 13. R equals, we have to include the variable here, R equals plus or minus 4 root 3. We feeling okay so far with this process? I see some heads nodding, thumbs up. That's great. Last but not least, this one's a little bit trickier, all the way at the bottom, number 18. If you look at 104, that's not really a multiplication fact that we've memorized in our youth, is it? So, what do we do? Well, if you don't know how to split up a number, I said this a couple times last week to individuals, ask yourself, is this number even or odd? 104. Is that even or is that odd? That's even. It ends in an even number. It's even. Every single even number we have can be divided by 2. So just cut it in half until you can't anymore. How many times would 2 go into 104? 52 times. Hey, look at that. 52, another weird number, but it's even. I can cut it in half again and divide by 2. How many times would 2 go into 52? 26. Perfect. Another weird number I'm not used to seeing all the time, but it's even. So I'm going to cut it in half again. How many times would 2 go into 26? 13. What type of number is 13? Starts with a P. Prime. So we can't split it up anymore. I've got a 2, a 2, a 2, and a 13. Don't split 13 up into like 6 and 7 because your brain's going to tell you to add. We're only dividing here. So x is equal to the square root of 2 times 2 times 2 times 13. Is there any pairs we can circle up now? Pair of 2's. Do I circle up all 3 of them? Nope, just the pair. This single 2's got to get left behind. Who can help me out? What's my x here going to be equal to? Final answer. Very close. What goes in front of the 2? Plus or minus 2 root. What do we have left over? We've got a 2 and a 13. I re-multiply them together and get, what do I get? 26. All right, so there was some confusion there on the end. We kind of touched all the bases that I wanted to. Bringing out 2 different pairs, we multiply them in the front. Having 2 different numbers left over in the square root, we multiply them back together. You guys see that similarity? Whatever's left, whatever we bring out in front, we multiply it together. All right?